Hi, and welcome to the ODU Wetlands Lab. If you're a part of this lab, it's no doubt that you will at some point be dealing with mud and soil. So today we're going to go through a few basic analyses that we do back in the lab to get a lot of good information out of a really simple collection of soil. So let's assume that you've already taken your soil core. What we're looking at here is a piano hinge core, and you should have a known volume of soil when you come back to the lab based on the diameter of the core and the depth at which you took it. Use a simple equation for the volume of a cylinder to figure out the volume of that soil. Should be in centimeters cubed. Coming back to the lab, you'll have a wet soil sample, so something that was freshly extracted from the earth, and with just a few simple measurements and a few simple techniques, you can gain all sorts of information from that, including soil bulk density, soil organic matter, and soil percent moisture. So if you have the volume of your soil core, you can bring it back into the lab and get the dry weight of it to figure bulk density. That is based on the mass divided by the volume, and your final number should be portrayed as grams per centimeters cubed. To get soil percent moisture, you need the wet weight or the moist weight of the soil and the dry weight of the soil. So if you take the moist weight minus the dry weight divided by the dry weight times 100, you'll get percentage moisture of that soil sample. So whereas soil bulk density and soil percent moisture can be figured with really basic stuff like volume and wet and dry weight of the soil, to get percent organic matter based on loss on ignition, there are a few more steps we have to take. So first, you need to make sure that you have a soil sample that is oven dried, usually at 60 degrees Celsius, and then pulverized. This can be done by hand using a mortar and pestle or by using the Wiley mill. Typically, we grind our samples down to about a 2 millimeter fine grain. At that point, you'll come over here to our analytical scale. And there's a few supplies you'll need. One is crucibles. You'll want to note the number or the specific ID of each individual crucible. And the first weight you need to collect is that of the empty crucible. Once you collect the weight, write this down in your notes, and then tare or zero out the weight of that crucible until you have a consistent zero. Next, you'll want to add approximately 2 grams of your pulverized soil to your crucible. This takes a steady hand and a little bit of practice, but the closer you get to 2 grams exactly, the better. After you've finished up all your crucibles with their 2 grams of soil each, the next step will be to burn it in a muffle furnace. Now the temperature at which the muffle furnace should be set and the duration at which you're burning your soil may differ slightly depending on the environment you're in or what you're interested in measuring. So make sure that you check the appropriate methods before determining the temperature and duration. But essentially, you would load your crucibles into the oven. For some methods, you can load them while the oven's cold. For others, the oven needs to be hot when you put them in, so again, make sure that you're checking the right methodology. I also recommend capping the crucibles so that no organic matter pops and disrupts other samples while they're burning. Make sure that the oven door is completely closed. To start the oven, you'll flip this switch with on. To set your ideal temperature, come to the left thermometer here, and you can adjust the set temperature up and down. What you can see now are 2 numbers. One showing the current temperature in the machine, the other showing the set temperature. So as you can see right now, it's currently 20 degrees Celsius in the lab. We would like the oven to be set at 500 degrees Celsius. The second thermometer you see here shows the override temperature. This is the temperature at which, if the oven should get on up to that degree, the oven will shut off. So once your appropriate set temperature is reached, you will turn on the machine by holding these two buttons at the same time. Oh, sorry, it's the other. There, you'll hear a click and a red light will come on. Once you have cooked your soil samples for the appropriate number of hours or time that you've determined, you have to come back and manually shut the machine off. So make sure that if you've turned the machine on, you're setting your own alarm to come back and turn it off at the end of its cook. So we just do a hard shut off, and you would open the machine, and depending on your analysis, you may want to let your samples cool down before you even come back. But if you want to retrieve them while they're hot, you can. Just make sure you wear the proper PPE. We have gloves and extension tongs so that you don't burn yourself, because as you know, it's very, very hot. After you've taken your samples out of the oven and they're cool enough to the touch, you'll need to re-weigh them once again. So again, make sure that you're taking note of the crucible ID, as you should have written that down earlier to correspond with your sample ID. You'll zero out or tare your scale and weigh the post-ignition weight of your sample and collect this number. Make sure that you are documenting both the empty weight of your crucible, the pre-ignition weight of your soil, and the post-ignition weight of your soil. And keep in mind, you'll have to subtract the weight of the crucible from your post-ignition weight to determine the weight of the soil inside. And there you have it. Take those numbers, plug them into this equation to determine percent organic matter. You can then use other allometric equations to determine percent carbon, perhaps, of the soil sample, depending on where you sampled, using existing literature.